Good morning, everyone. Nice to see everyone with bright eyes. I always appreciate the attendance for a morning session. Sometimes it's a struggle to get up and get to the show floor after you spend an evening with your coworkers and others, connections that you meet when you're at a trade show. My name is Vaughn Stewart. I'm with NetApp, and joining me is Glenn Sizemore. We both work in various technical marketing groups. I'm Glenn being the technical marketing side of the Microsoft business unit. I'm technical marketing side of, marketing. So we are going to share with you today a conversation around delivering IT agility to a modernized data center and really focus on the construct of storage integrations within virtualization and cloud constructs. We've got roughly 5 to 8 minutes of content, and then we will open the floor for questions and answers. And before we get going on that, I just want to let you know that we have lots of content going on in mini theater sessions in our booth, roughly 7 per day. The schedule is not set rigidly to any time frame, so I can't tell you exactly when to stop by, and it's too lengthy to read. But a number of the conversations that we're going to talk about here are covered in the booth in greater depth and detail. So if there's something of interest and you want to know more, please stop by. So here's briefly the agenda that we will take you through. Are we leaving time for Q&A? Okay. So that we have 75 minutes together. We will leave roughly 10 to 15 minutes for Q&A at the end. So if something comes up, and I know sometimes hands come up in the middle of it, do you like to interrupt when you're in the middle and take Q&A, or you want it all at the end? Huh? Okay, perfect. So I'd like to introduce you to NetApp. Hopefully everyone in the room is well aware of NetApp, and you're all NetApp customers. Actually, by a show of hands, can I see anyone in the room a NetApp customer? Great, I appreciate your business. So that was about half the room. So for those of you who maybe don't follow NetApp as closely or are yet to be a customer, we're a Fortune 500 company, actually entered the list last year. Our flagship product is our Data on Tap. It's our storage operating system. It is measured as the world's most deployed storage operating system. We will speak to some of the capabilities of Data on Tap specifically as we start to go through our product line and into our integrations. And you should, from that point, become very clear why it's the number one storage OS, and probably not for maybe what you may assume as I'm setting this up. We're consistently ranked as one of the best places to work. As of last year, the number 3rd best place to work in the world from multinational workplaces. From Fortune's top 10 list, we ranked number 6 for 2013. We're also highly recognized as being an innovative company. We are very technology-centric. Hopefully you'll gain some appreciation for that as we go through the content today. But as you can see, Forbes recognizes us in 2012 as one of the most innovative as well as one of the fastest growing companies. I think if I were to summarize NetApp and why we drive this growth rate and this type of recognition is that we don't look at storage solely for storage sakes. I think a lot of times in the building of a data center, we tend to consider storage late in whatever the application that we're deploying. And NetApp has always had a long-standing vision of trying to drive a greater means of agility with the application of the data and the data management constructs into a business process. And as we go through some of this would probably be an overarching theme. We recently were just awarded Microsoft's 2013 Server Platform Partner of the Year. We've also in previous years been the Private Cloud Partner of the Year and a finalist for Management and Virtualization. I think this year's award really stands out from a perspective that we're a storage company. We don't sell a server line or a server platform and products. And I think our focus on driving that data management into the higher levels of the infrastructure, whether it is at the management and provisioning layer, all the way up through the actual application and operations by an application or development team, really speaks to why we were awarded the Server Platform Partner of the Year. Our focus isn't on storage. It's actually helping customers run and operate their business and meet the needs of their customers. So here you can see this list of integrations, and we've broken it out by layers. I would say that the cloud computing, or maybe even the predecessor of server virtualization, really started this initiative that on a broad scale started having storage vendors and other technology partners drive greater integration throughout this stack. And a lot of the partners stop at the, say, server or hypervisor layer. And as you can see here, whether we're talking about actually the provisioning and management of hardware through the hypervisor layer into workflow automation and application management, as well as trying to automate and orchestrate the workflows, and particularly the multi-components of actually delivering services to an end user. You can see we have a rich set of features here that we are going to dive into when I turn the floor over to Glenn. Before we dive in, though, I want to start at a very high level and talk to you about an emerging data center trend called a software-defined data center. If you're unfamiliar with this concept, software-defined data centers is an emerging architectural design, really building from the origins of server virtualization and kind of filling that gap between server virtualization and where we are today with cloud computing initiatives. The construct of a software-defined data center is driving greater agility to your end user or your consumer, which should be thought of as an application owner, a development team. And this agility is powered by virtualizing every layer within the hardware stack and allowing that those hardware devices to be orchestrated and automated in conjunction with virtualization layers like virtual machines, etc., for the delivery of services. And by having that level of extraction, it's much easier to then have a programmable set of interfaces and tie these into self-service portals and workflows, as well as set up management constructs like policies and role-based access, etc. There's some other additional constructs that make up a software-defined data center, which is to really focus on the delivery of your resources in the forms of policies and not as hardware devices, and to really become hardware neutral as best possible. And hardware neutral is really a unique proposition from a storage perspective because by and large the storage industry is comprised of vendors who make products for a particular set of functions. So you traditionally buy enterprise class SAN array or a scale out NAS device. You very rarely find vendors who are focused on delivering both functions out of one piece of hardware. So what's software-defined storage? Software-defined storage is one of the pillars of a software-defined data center. If I consider that I'm going to abstract or virtualize all the layers of my data center, I've got a compute layer, a networking layer, storage, in some models a security layer, and again, these are all brought together by automation. And why software-defined? I think to address the common set of business challenges. I think technology evolves constantly. I don't think the business drivers ever go away, right? It's reduce cost, it's accelerate business, and these are just sub-bullet points to those overarching goals. If I'm in a software-defined model, I have different sets of values depending on what my role may be. If I'm in IT operations, what I want to receive is I want the ability to translate agility into business responsiveness. I want to be able to better meet the needs of my application owners, get away from hardware-defined constructs, instead of look at service levels and policies. If I'm an application owner, I want to be able to consume on demand. I want to hit a portal or an integrated tool and say my application needs a certain set of resources or a certain function, whether that's backup and restore, whether that's increase my storage capacity or storage performance. Maybe it's something that's above storage, increase the number of CPUs, etc. I want this autonomy. Right? I want to be able to operate within the corporate policies that govern what options are available to me, but I want to be able to do so on demand. And then if I run IT, if I'm a part of the purchasing and decision-making team in that space, I want flexibility and choice. Right? I'd like to know what your software offering is, but I'd like to be able to take your software offering and be able to see which hardware vendors best provide a platform that meets my business requirements, whether it's my core data center or maybe somewhere out on the edge. And so with this, I'd like to share with you a high level of our software-defined storage vision and approach. And then again, from when I present the high level, I will then hand this off to Glenn, who will dive down into a number of our enablements where we're actually delivering on this today. So we've got three categories: application self-service, virtualized storage arrays, and support for multi-vendor hardware platforms. So what you see on the screen here is an oversimplified depiction of our storage platform. This is called Cluster Data on Tap. This is the latest release in our Data on Tap software line. As I stated in the beginning of the session, this is the recognized globally as the #1 storage operating system. In this version of Cluster Data on Tap, a couple of highlights that I will share with you. We've moved away from a historical model of a 2-node storage cluster providing active-active arrays to now a 24-node storage cluster. This provides a significant amount of scalability from a hardware perspective. You're able to mix and match the storage controllers within the NetApp line, and that's to be depicted here in these different size NetApp controllers on the screen here. But they operate as one logical cluster. And all storage access in the cluster comes through the construct of what we call a storage virtual machine. This is a virtual or software, or I should say logical abstraction of storage resources from the hardware. The storage virtual machine can be comprised of resources that are stored on a single controller or can span resources on all of the storage controllers. And that ability to assign hardware resource to power the services of the data set in the storage virtual machine is done dynamically and without reconfiguration of any of the access points above. And what I mean to clarify by the reconfiguration of the access points, this means I shift away from provisioning hardware to support a business need, and instead I move into a policy model. I'm a storage administrator, I make a storage virtual machine, and this may be for SharePoint server. I may make another storage virtual machine, and it's for my Exchange environment, and a third that's going to be my SMB home directories and shares. I can delegate control to the application owners for each of those systems, and I can assign service levels, whether it's quality of service for performance, whether it's an integrated data protection policy that's doing application-based backups and replication for disaster recovery off-site or into the cloud. Right? It allows me as a storage admin to set up the rules, capacities, and limits that then I hand off to the application owners. If I change the hardware underneath from that application owner, they never reconfigure access. They have no idea that the storage devices below are interchangeable. So in a lot of ways, this is very similar to what we've seen over the last, say, 8 years or so with server virtualization, where virtual machines run separate from the actual hardware that they reside on. You have an abstraction layer called a hypervisor. You could consider Data on Tap as a storage hypervisor. So this is the first level of our software-defined policy. Move storage services away from hardware devices and into software-based containers that can span or move across various hardware on the NetApp family. We support more than just NetApp hardware, and this is our second layer where we talk about providing support for multiple vendor platforms. So today, Cluster Data on Tap runs on NetApp FAS line. That's what we share with you in the first slide. We also make Data on Tap available for existing third-party arrays that's delivered through what we call a V-Series, which is a hardware device. Unfortunately, while we're talking software constructs, I can't just load my OS Data on Tap on other storage controllers. The hardware that comprises storage controllers is vastly different from vendor to vendor. They're very proprietary in their design. So there is a quote-unquote gateway device to provide you a standard set of functionality in the software. But it does provide a new set of capabilities onto hardware platforms. So for example, if I take a SAN-based storage array from any other vendor, be it HP or EMC or whoever that may be, and I put Data on Tap on it, I now get a standardized set of APIs. I get receive storage virtual machines. I have access for SAN and NAS protocols, data deduplication, integrated data protection, et cetera. In other words, I up-level the service and functionality of those controllers. I also standardize it with the NetApp offerings. We also have the ability to run Data on Tap on servers and turn local disk or direct attached storage into shareable storage pools. And we offer that today with Data on Tap. We will have cluster Data on Tap support coming this fall. So it does run Data on Tap today, not in the clustered configuration with storage virtual machines. So this part is a future, but a very near-term future. As well as we now make Data on Tap available in the cloud through cloud service providers. And that's provided specifically today with NetApp Private Storage for Amazon Web Services. And that portfolio of service providers should also grow as we go through the fall. Look for some forthcoming NetApp Cloud launch sometime in September. The bottom line here is what I shared with you in the first screen about what we can provide within Data ONTAP and the abstraction of software services into virtualized containers doesn't just run on NetApp hardware. You can have ONTAP or the enablement available, whether it's on your hardware, existing hardware that's in your infrastructure, or you want to go out to the cloud. Then last point that I will share with you before handing over to Glenn is all of this software-defined conversation points are meaningless if at the end of the day we're talking technology for technology's sake. The goal of working in an IT, working in a data center or a service provider is servicing your consumer or your customer. And that may mean your application, again, reinforce application owners, development teams. And so this is going back to the part of the reason why NetApp was recognized as the 2013 Server Platform Partner of the Year. It's our ability to drive through an open API set, a set of integrations for standardized enterprise applications, as well as being freely accessible to development teams to empower application owners to consume storage resources through all this underlying architecture that we've built. You can hear conversation points in the software-defined space where people talk about the control plane and the data plane. You hear that specifically in like software-defined networking. I think the RAID subsystem, that is your data plane. That's where you store data. That's Waffle. That's our file system. I think the control plane is the storage virtual machine where you set up policies for consumption. I think this is called the consumption layer or the application layer. And this is where these teams get to leverage their APIs to accelerate their business. So I'm going to, instead of going through some of the details and giving you just a product name drop of what we do, I'm going to hand over to Glenn here and let him take you through a number of examples of where we're executing in this space. Fair time to change?
Sure.
Give him some meat?
Yeah.
All right. Thanks.
Okay, so that's who NetApp is, and that's what we do. So now we're going to shift gears a little bit and kind of target in on what we've done recently to enable the Microsoft environment and the Microsoft private cloud in particular to achieve that better agility and to realize these software-defined data centers and these constructs today, right? Not just a future idea, but something that's ready to be installed and configured now. So for us, in this instance, the platform that we've been given is Server 2012. Right? Microsoft did a fantastic job of just going back and starting over in a lot of ways and reimagining what was necessary to give what they've now decided to call the Cloud OS, but you know it works for me. It's got the abilities and the plugins that we need. Now, Server 2012 obviously came out a year ago. It's been out a year. A year later, we're still trying to grasp and deal with all the integration points that and the new features and functionality that came with it. But for the purpose of today, we're going to focus on 3 of them. It's a huge product. There are sessions all over this entire mile-long facility that are targeting little subpieces of it. We're obviously not going to get through all of it. But for the purposes of storage, right, we're going to start with management, and then we'll go down through some of the stacks and some of the new features and capabilities that are enabling us to build these platforms today. So management, for us, in a Server 2012 environment, gets broken down into a couple of different categories. All of them, first and foremost, standards-based. That's become a pivotal decision. Instead of driving proprietary systems, the decision to go and adopt standards-based management and to drive the management plane through standards then gives third parties like NetApp and our competitors and everyone else here the opportunity to innovate and to deliver new experiences and new capabilities. In the Microsoft private cloud environment, that integration, the primary integration and the one that is the most critical is PowerShell. Today, in this world, PowerShell is now the truck that you're going to get the majority of your integration, your custom apps, and going forward, the configuration management of the data center done. That's just how it's going to happen inside the Windows world. There are other tools for other OSs and other integrations, but Microsoft's made it pretty clear that PowerShell is how Windows is going to do that. So at NetApp, we've gone ahead and invested heavily in making sure that Data on Tap can be a first-class citizen in that environment. And we do that through our Data on Tap PowerShell toolkit. It is a wrapper around the NetApp Manage on Tap SDK. Now, this SDK is freely available. It's a publicly documented API. So any developers who want to bypass our integration point and go directly to the array, they can. But we provide PowerShell to make it easier for day-to-day administrators to just operate at the orchestration level, not have to necessarily get down into the development guts of how it works, and just think about it from a common language perspective. And we'll see that here in a second. Our toolkit is community-driven. What that means is when we sit down and plan a product sprint for the next release, we don't go to a bunch of program managers. We go to a forum and we ask our users what we're missing and what they need. And we take direct feedback from them, and that's how we prioritize where we're going. And that's what's led to the wild success of the product, because we've relied on this vast base of extremely intelligent engineers that told us what they needed to make our products better and what they needed to make the integration points work. And through listening to that feedback, we've been able to focus in on the problem areas, and we found some pretty unique stuff and developed some killer capabilities that we're going to talk about. But then, there's Microsoft they have to handle the entire industry. Right? I happen to believe that NetApp's one of the good ones. Of course, I work for them, so I would say that. But our industry is not full of good ones. There's a lot of what I like to call poison pills in the data center that don't necessarily follow along. So for that purpose, we're now dealing in this world of abstractions. And now we've got the data center abstraction layer, right, and the cloud OS and the industry self-service. And driving through those standards-based interfaces, Microsoft is taking control from the management plane of not only the OS and the hardware and the VMs and the hypervisor, but now they're starting to reach out into the network and the fiber channel SAN, right, and into the storage. And for us, that particular integration comes through our SMIS agent. Our SMIS agent through storage spaces and through SCVMM. It gives Windows the ability to completely manage all aspects of Data on Tap. Fantastic way of going along, especially if you're a heterogeneous environment and you have multiple different vendors and you want a single control plane. Makes a ton of sense. The problem with it is because it's standards, it's the least common denominator. And we got a lot of guys dragging their heels. So there's some of the latest and greatest and most bleeding edge technologies that are enabling these next generation engineering designs aren't in the protocol. They're not in the protocol because 2 out of 60 vendors support them, right? So that's why we recommend and we lead with PowerShell, but we do have proper support of the standards-based approach if that's what fits in your design for you. And then we have our traditional software product that Snapdrive for Windows for NetApp customers. We've had Snapdrive's been around for 10 years now. We still offer it, but it's kind of being depreciated a little bit. It's now just a backup tool. So if you're using our Snap Manager products or you're using us for hardware-based snapshots, Snapdrive is the facility to get there. The management is now through the front door of Windows. So that's the management extensions brought in Server 2012. And I know it sounds kind of boring, quite frankly, but when you start to get to the scale, when you start to realize what a software-defined data center and an agile data infrastructure really is, then you start to run into these roadblocks of, okay, well, yeah, I can do that in Windows, I can do that in Windows, I can do this over here, but can my storage, can the rest of my data center meet that flexibility? Can it keep up with those requirements? And that's why, from an API perspective, we're focusing at NetApp on making sure that our platforms can be that agility and have the integration points, not just from a programming developer point of view, but from the admin point of view, from the guy who's actually building it. Because the way that these things are being constructed these days, around the world and all the customers we talk to, it's very little custom code and it's a lot of just workflow scripting. That's how the real world's building it. So that's the model that we're supporting. So let's take a look at what this looks like. Have you guys seen the SMIS integration in Server 2012? Show of hands. No? No one's ever seen this stuff. It's so cool. Okay, so here we've got Failover Cluster Manager, and we've got a 2-node cluster, and we want to provision some more storage. So what we're going to do is we're going to go into Server Manager, and we'll wait for it to load. And then we're going to go to File, Storage, and Spaces, and then we'll go to Storage Pools. Now, most people think this is just for spaces. It's not. This is the abstraction that Microsoft has done to make the entire data center come under a single umbrella. So here, Storage Pools is reaching out through our SMIS provider and is talking directly to the NetApp array. Here you can see our aggregates, and the disks that make up those aggregates are listed. And we're going to create a new LUN. But because it's a flattened namespace, it's called a virtual disk, because this could just be a VHD sitting on spaces or ReFS. But in this case, the provider is talking directly to the array. We're going to pick a pool, which in this case is a NetApp aggregate. We'll give it a name, which will be the name of our LUN. We're going to thin provision it, of course, because we want to maximize our efficiency. And we'll make it 500 gigs. We'll select the fiber channel ports that we want to zone this out to, and then just hit create. So real simple, from inside Windows, inside the Server Manager wizard, 5 clicks, you go. And of course, since we're using Server Manager, this could be ran on one server talking to 50 or 100. And since we're using Server Manager, this is all available through the built-in commandlets for storage spaces. Right, so this is standards-based management. This is the advantage of going with standards. Here we're going to finish it out. We'll just put a quick partition on it. We're not going to sign a drive letter because we're going to make it a CSV. And we'll see it runs through very quickly, formats the volume, puts it in the cluster, and updates the cluster cache. So now we'll close that out, pop over to Failover Cluster Manager, and we'll turn it into a clustered shared volume. That's simple. 90 seconds. Now, at NetApp, we always recommend from an operational perspective, you always rename this stuff inside Hyper-V. Whenever you deploy a CSV or a cluster resource, rename not only the resource inside Failover Cluster Manager, but also rename your mount points and make sure they match up. This is just an operational tip, stuff that we've learned through escalations through our customer support services. Just best practices. If you keep everything named the same, give it logical constructs, it just reduces human error, reduces risks, and it makes it easier to manage. So that's the standards-based approach. That's SMIS. And we actually think that Microsoft did a fabulous job with this. But again, it's least common denominator. So now let's take a look at what's available when we go upstack and we take on the challenge of doing a little bit of custom work. This is our Server Manager product. This is the GUI for NetApp, if you will, for those who still prefer it. Here I've got a cluster data ONTAP cluster with 4 storage virtual machines. So I've got a 2-node physical hardware device, and I'm running 4 logical SVMs. Now I want to onboard a new tenant into our cloud infrastructure. So what we're going to do is we're going to run a single script that's going to provision a new SVM, so a new container for our client. But then we're also going to provision the data lifts, the volumes, the LUN. We're going to add it to the cluster, and we'll do this all in an automated fashion. So you'll see here we've got 18 lines of code. Extremely simple. We're not going to go through it. If you want to come down to the booth and talk through it, we can. It reads like an English sentence, which, by the way, is a sign of a good PowerShell design. If it looks like programming, go talk to your vendor. They didn't do it right. It should read like a sentence. So you'll see here we go through, and we've already created the LUN. Took a whopping 15 seconds to provision everything out. Now we're waiting for it to VDS to get the disk arrival notification, bring it into the cluster so we can update the cache. And you'll see there you go. Complete end-to-end. Not only do we have our CSV in Windows, and we've renamed those mount points, so we are maintaining best practices, but we also, if we hit refresh, we've updated the container inside the cluster.
Dumb mistake. Don't turn your mic on in front of the speaker. I wanted to point out one thing real quick, and I'm sorry to interrupt you. One of the things that I think is very unique about a NetApp storage platform is this construct that we don't pre-provision LUNs and then wait for you to come and consume them. We take all the disk drives and we basically RAID protect them, grouping the disk drives based on drive type. So we match up the same type of, say, SAS 15,000 RPMs or SSDs or deep and cheap SATA drives We may do hybrid configurations of solid state with the spinning media so that you have a performance cache with them. But we basically are making what we call aggregates, basically pools of capacity based on storage tiers. When Glenn just created this LUN, it kind of hit me, which was we make those all on demand and on the fly, and those are all virtual and logical as well.
Yeah.
So just wanted to be clear there. If you have storage experience with another vendor, that's probably very different. What we do is probably.
Yeah, that's the key point there. So we had to step out of the built-in tools, and in this case, we're staying in Server 2012. We're staying at the base level to show that, SCVMM obviously makes this easier. The higher up stack you go, the easier it gets, and the less integration work you have to do. But if you're willing to go to the bottom of the stack, you can get it incredibly cheap. Now, everything that we just did there is server and data on tap. That's it. Everything else is free. Everything's publicly available. There's a broad community to help support the development, right? So if you're willing to do a little bit of work, you can get a lot of power and a lot of high-value reuse out of the platform to build that and realize those software-defined models. So that's kind of a real quick and dirty overview of management. If you want to deep dive on any of that stuff, we brought everybody. We've got our SMIS experts, PowerShell developers, everybody. Just swing down by the booth and we can deep dive on any of these topics. So what else did they do? What else did Microsoft do that enables us to build these next generation data centers and these agile data infrastructures? Well, one of the key points was performance. Right? Server 2008 R2 was a capable hypervisor, but it was not capable of hyperscale. Server 2012 has changed that. We now have a hyperscale hypervisor that is ready for the cloud OS. And it's not just the I/O stacks and the driver packs and all the optimizations that they've done in the hypervisor and the network throughput to make everything just get through the operating system faster and drive the hardware harder. They also did a lot of work in the protocol space and giving vendors the advantage and the option of extending on those protocols and giving you, the end user, the ability to get more for less. And one of the key offloads that they provided was offloaded data transfer, or ODX. You guys heard of ODX? Show of hands. Handful. Okay. So for those of you who haven't heard of ODX, it's a copy offload engine. My VMware counterparts like to refer it to VAI. It's a poor analogy. Yes, they both do copy offload, but the way that they do it is not even kind of comparable. One of them is a SCSI command that offloads the copy to the array. ODX is a token-based protocol. That's a key indication and a key differentiator. The reason for that is what happens is Windows Server takes a source file and it queries the storage device and it says, are you ODX capable? And if the storage device says yes, it breaks the source file up into tokens. It then sends the tokens to the destination. So we're moving little tiny tokens, not actual data. The destination takes the token and it drops it on the destination storage device and says, do you know how to get to this? And if the destination storage device knows how to get there, it comes back and says, yeah, I got it. And now the storage device handles, however it does it, it handles the actual transfer. Meanwhile, Windows is just flying tokens back and forth. So not only are we offloading the copy to the array, but since we're micromanaging this token-based system, we can provide up-to-date real-time status of where we are in the transfer process. And if the offload fails for any reason, the host can pick up at exactly where the offload failed and just fall back to a host-based copy. This is offload done correctly. And it's a tool that has given us the ability to give you performance that is otherwise not possible, not only from a speeds and feeds perspective, which quite frankly I'm not very interested in, but from an efficiency, from a bottom line, bottom dollar, brass tacks point of view, which is where we've really focused. It also gave us the ability, since we do have a unified platform and unified protocol access, to leverage this protocol to make it cross-protocol, because there's nothing in the specification that says must be a SCSI command. It just says you drop the token. You could drop the token on a Fiber Channel LUN, you could drop the token on an SMB share, you could drop the token on an iSCSI LUN. And in NetApp, if you drop the token, we're going to offload the transfer. We have multiple different offload engines. The one that's going to get the maximum offload is our FlexClone technology. It's also the one that's going to give you the maximum efficiency. But bottom line is, if you pick it up and drop it anywhere in a clustered data on tap cluster, we're going to offload the copy. right? So this is a fantastic value prop. And even if you're not interested in NetApp, ODX needs to be on your RFP list. Demand this. It's that important. And it's just going to get even more, especially with the next iteration of SCVMM, now bringing ODX into just basic provisioning and how we do business. So let's take a look at what ODX looks like. Again, we're not going to do speeds and feeds because I'm not really interested in that. That's fun for internet videos, but it's not where people actually use the product. So for a real-world instance of what this looks like, we're going to take a VM that's sitting on an SMB share, and we're just going to move it. We're going to use the built-in tools, nothing special, nothing fancy, no custom scripts. We're just going to run through the GUI. And we're going to move it to an SMB share where we have artificially disabled ODX. So we've turned it off. This is going to be our baseline. This is a host-based copy going through the network. And we'll get it going. Now that that's running, we're going to take our second VM that is sitting on the same SMB share. So we're coming through the same data pipe, the same bus, and we're going to move it as well. This time we're going to move it to another SMB share. And here you're going to see the power of ODX. You'll see the ODX-based copies already caught the host-based copy. At this point, the VHD is already flipped, and now we're just waiting on the memory streams to be updated. Done. So now while we're still waiting on the first base copy, let's go ahead and we'll move it again. This time we're going to move it from an SMB share to a CSV running over Fibre Channel. Now again, this is cross-protocol. We're going from an SMB share to a Fibre Channel 1. And here we'll zoom in so you can see the actual cutover event. There you have it. Now under the scenes, how do we do that? Well, we put multi-billion-dollar devices with terabytes of RAM and all. No. We cheated. We didn't actually move anything. That's the power of data on tap. That's our unique advantage. This is why we have this intelligent operating system. This is why we have the world's #1 storage deployed OS. We're just swung pointers, right? On the back end, we used our core technology, our FlexClone technology, to swing some pointers and to tell the OS, yep, okay, now it's over here. But on the back end, we never actually had to write any data to the disk. We wrote metadata. Now, here we're doing it with a live migration to accelerate storage migrations, but the same thing happens anytime you initiate a Win32 copy inside Windows. So anytime you do a Control-C, Control-V, it's going to attempt to do it through ODX. And it'll attempt to do it from ODX even if you're inside a VM. So this is going to offload copy across your entire enterprise continuously. And in NetApp, we're going to leverage that FlexClone technology to not only give you accelerated copies, but to give you space-efficient copies, near zero space-efficient copies, right? So we're very excited about this. This is wildly important. And again, even if you're not interested in NetApp, this is on your list of demands when you talk to any storage vendor. It's that important, and Microsoft's going to continue to iterate on it. So what else did we do for performance? Well, we've got all these VMs that are running inside Hyper-V now. How are we going to back them up? Backup and restore inside large cloud deployments is actually kind of problematic because the number of objects that we start to run into. NetApp, our solution for that is our Snap Manager product. It is a hardware-based snapshot provider. We have the ability to do crash and application-consistent backups. We'll get into the difference here in a second. We do implement distributed backups in CSV v2 in the CSV file system. We'll go through why that's so important here in a second and show you the vastly improved performance that we get in Server 2012. And because we're in an SMB world now, we're not just talking about blocks and LUNs, we also support remote VSS, which is the methodology to trigger volume shadow copy services on a remote SMB share for VMs running over SMB 3.0. So what's this look like? This is not exciting, but that's the point. Backup's not supposed to be exciting. It's just there. This is your last safety net on the way down the tree. This is the branch you grab before you get fired. That's its job, right? So we're going to go through, we're going to do an application consistent backup. We could do DR, we could integrate Snap Mirror and Snap Vault and do pre and post scripts and get real fancy with it, but here we're just going to back up 3 VMs, take a hardware-based snapshot, near zero space, snap our snap info, and we're done. That was real speed. We didn't speed up anything, right? But that's 3 VMs. That's not performance. What's performance? Well, I'll show you what 2012 did. Now, we're not going to talk about how much faster we are than other backup options. I'm just going to tell you how much faster we are with our own product. Now, and you can use the backup times and judge for yourself how much faster we are than other backup products. So if we take a look at Server 2008 R2, without distributed backup and with the VSS stack that we were given in that product, our Snap Manager for Hyper-V product version 2.0 takes 140 minutes to back up 500 virtual machines running on 4 physical Hyper-V hosts. We back up 1,000 virtual machines, application consistent, so every single VM has got Quiesce I/O all the way through the file system, in about 300 minutes, actually 302 minutes. That's not good. And we got our butt kicked for the past 4 years from our customers, continuously hitting us over the head going, this is not cutting it. But to show the point, we were working with what we were given. So we came up with a concept we call crash consistent, where we don't go through and we don't talk to the VSS writers at all. We just take hardware-based snapshots. In 2008 R2, the crash consistent backup, 500 virtual machines, took 13 minutes, and 1,000 virtual machines took 44 minutes. Now we were starting to get inside the windows that our customers were demanding and that the cloud infrastructures demand. So along comes Server 2012 with an enhanced WMI stack, an enhanced VSS stack, and the distributed backup capability in CSV. In Server 2012, we're able to do an app-consistent backup, so Quiesce every single virtual machine on the cluster, 500 virtual machines in 30 minutes, 1,000 virtual machines across 8 physical Hyper-V hosts in 62 minutes. So now we're getting app consistent in the time that we were just getting crash consistent. So now we start to get to the really exciting part. If we still go crash consistent, which by the way, let's remember that Windows is a journaling file system. It's built to have the power yanked out at any point in time. It's fine, right? With the exception of stuff like Active Directory and home-based apps that rely on Quiesce file systems, most app servers, especially if you're running something like SharePoint, Exchange, SQL Server, well, the OS itself can have a crash consistent restore point. You're going to bring the app back from an app backup, right? So those are 2 separate jobs. So if we take that viewpoint, what kind of RTO can we look at? What kind of performance can we get? Well, a crash consistent backup in Server 2012, 500 virtual machines in 8 minutes, 1,000 virtual machines in 12 minutes. So now we can realistically start to look at an environment where we can back up, have full restore points for every virtual machine every 15 minutes continuously. That's next generation agility. That's the software-defined models and the ability to offer services that are otherwise not available. Not only rapidly provision these resources inside a cloud environment, but then the ability to offer data protection to the tenants as a service. Most cloud systems don't even think about backup because it's too hard and it's too time consuming. So this is a real differentiator if you're implementing any kind of private cloud infrastructure to offer to your customers. Not only can we rapidly deploy the service, but we can offer you data protection as well. And if you're using NetApp, this is where it becomes a product pitch, our near zero space snapshots, you get this almost for free, right? Because the snapshots aren't copy on write and we only store the difference in the metadata. So it's extremely performant from a performance standpoint and consumes next to no space. So those are the 2 primary points from a performance standpoint that we talk about inside Server 2012. How many of you are VMware customers? Put your hand up. Everybody is. Of course you are. They didn't invent virtualization, but they sure as heck made it successful, right? Now the problem is now we've got Server 2012 and we've got an actual horse race in our hands and we've got an actual choice across the board. How are you going to get there? Well, at NetApp we've looked at this problem set And we've said, well, let's see what we can do. We've developed a transition technology that works with any Windows VM Server 2003 or newer. It is an order of magnitude faster than any copy-based migration technology. It is space efficient. We're leveraging that same flex clone, that same core trick. And it's Windows PowerShell based, so it's ready to be extended upon. We file this one under portability. This is another requirement that you need to have when you start to realize these software-defined models in this agile data model. Not only does it need to be performant, it needs to be manageable, it needs to be standards-based, but you need to be able to move a tenant, you need to be able to move an application. In this case, we need to be able to move from one container, VMware, to another in Windows Server 2012. So now let's take a look at what this looks like. This is a technology that we're currently using the term container shifting, so we're calling it NetApp Shift. It doesn't actually have a name yet, but I think Shift's kind of cool. So here we have our old friend ESX. This is version 5.1, latest and greatest, and we've got 29 virtual machines that are up and running. We're going to hop over to our Hyper-V environment where we have no virtual machines up and running. We're going to run a real simple PowerShell script. We're going to connect to ESX. And now we're going to connect to data on tap, and we're just going to enumerate all the virtual machines that are on that source ESX cluster. We're going to use Out-Grid View for you PowerShell aficionados in the room to put a real light UI on this solution. So here we're going to go to the Out-Grid View option, and we're going to select our VMs to migrate or to shift from that VMware container to the Hyper-V one. In this case, we'll move them all. We'll just go through and we'll create a VM. We'll convert that VMDK to a VHDX file. And then we'll mount the VHDX file and then start the VM. Now, I sped this up a little bit so we can get through all 29. The problem that we ran into when we started talking to customers is they say, yeah, we love the value prop. We love the fact that we get Server 2012 basically for free since we're already licensing the Windows version. But I can't get the outage. I can't get the downtime. I cannot take the business down for 4 or 8 or 2 days while I move data. The question that we've been asking this week so far is, can you get 12 seconds? You think you can get that? We bet you can.
Actually, I would add, if you think about what it would take to migrate between platforms, not just from the downtime, but I believe the configured capacity on this is 1.1 terabytes.
Yeah, 1.1 terabytes.
So this is just a small environment, 1.1 terabytes. If I was going to really do an import and export of data sets, I've got to have another 1.1 terabytes of free space. If I'm replicating that data, I've got to have bandwidth time to sync it somewhere else. I've got to worry about where are my backup copies, particularly if there's snapshots on disk. Do I have to retain those? Do I orphan those? What's going on? There's a lot of infrastructure requirements besides just the regular downtime
Absolutely.
to move all that data, and we've just taken that off the table.
Yeah. So again, on the back end, how do we do that? Well, we took that base VMDK, which is running in an NFS data store, and we flex cloned the data blob out of the VMDK and into a VHDX. So the difference between a VMDK and a VHDX is the headers and the footers, but the data blobs are the same. They're both just blob storage, right? So all we do is we take a VHDX file, we put proper footers and proper formatting, and we just flex clone the data, so we don't actually move anything. We just swing pointers from the VHDX into the VMDK. Now with Server 2003 migrations, if you happen to have VMs booting off SCSI, and if you built them in ESX 3.5 or 3 and previous, they were booting off SCSI because IDE wasn't an option, we do have to mount the VHD and do some custom driver injection where we push the IDE driver and update the boot INI file so that they'll actually boot at the other end of the conversion. But if it's 2008 or 2012, you don't need anything. We have a self-healing operating system. It shuts down in VMware. We flex clone the data blob. It starts in Hyper-V, right? The VM comes up, VMware tools just time out. The Hyper-V integration services go, oh crap, Hyper-V, okay. They start, reinstalls all the drivers, and in about 5 minutes total time, 12 minutes conversion, 5 minutes total, because you got to actually wait for the VM to come up and install the drivers, you've flipped. Now the reason this is a technology preview and not a product is because there's still a lot of work that needs to be done. Right? The network, for instance, if you're using static IPs, that you're going to have to reconfigure those. If you're using DHCP, you have a new MAC address, so you're going to have to update that as well. There's Active Directory concerns. There's stuff besides the data move. But the primary thing stopping our customers from realistically considering migrations at scale is the space problem. It just takes forever to flip these formats using traditional copy-based methodologies. So this is a technology where we're investing heavily, and we're working closely with partners to try to bring to the masses in a tool-based format to make it quick and easy to shift between platforms. Now here we focus specifically on the VMware Hyper-V because we happen to believe that's the heaviest use case, but this works for more than that. We've got previews where we're shifting from ESX to Hyper-V, Hyper-V to ESX, ESX to Amazon, Amazon to Hyper-V. So it's cloud shifting, it's container shifting. When you pick data on tap, we give you the ability to shift in between any of these containers and put the compute where it's most cost effective for you at that point in time without requiring your tenants to do constant rebuilds. Okay, so that's actually just the base. That's the start. We haven't even really got into cloud yet. That's just all that deep integration and that engineering work goes into just making Windows better and propping up the server team and making all of their hard work, just kind of lighting up those endpoints and those APIs so you can get the maximum out of it. So now let's take a look on the other side, in the data center management side, take a look at what we offer for a Microsoft private cloud infrastructure. For us, this integration comes through a product we call On-Command Plugin for Microsoft. The currently shipping version is version 3.2. And we're going to focus on three primary integration points today. The first of which, of course, is Operations Manager. Operations Manager is the System Center product that's got the widest adoption. It is the one that just about everybody has. It's a fabulous monitoring product. We have a first-class management experience. Our management pack brings in all the deep storage management constructs and logical objects from data on tap into SCOM to give SCOM the ability to then start connecting dots, right? This is we like to think of it as a nice and neat central management UI for Windows admins. So this isn't a storage management tool. If you're a storage guy, then you've already got tools. But if you're the System Center guy and you don't know jack about storage and you're not interested in learning about it, this is a way for us to educate. Not necessarily teach you the constructs, but to give SCOM the information it needs to give you intelligent alerting, to be able to say, this SQL server is failing because this LUN is failing, and this LUN is failing because this aggregate is underperforming because you lost a spindle, so now you're doing read builds, so your latency's gone up. That's the end game. Zero-point root cause analysis at the application layer based on what the hardware does. SCOM gives you that as long as you give it the information. And in this case, we give it that information through our SCOM management pack. Now, for those of you who happen to use the data warehouse in SCOM for long-term availability, data reporting, or any of that stuff, we also ship sample reports. Of course, if you're doing this, you know how to write your own, but we do ship 17 sample reports for you to use. And then, of course, we offer SCVMM pro tips. We currently have 17 of them that are targeted at what our support services were most often running into in Hyper-V deployments, right? So we took the problems that we were seeing the most often in the real world, and we brought pro tips to automatically remediate those issues. So honestly, guys, at this point, SCOM integration is table stakes. If you don't have it, don't even enter the conversation. So this isn't, for us, it's the same. It's table stakes. We've had it for 9 years at this point. But we still believe that our integration is above and beyond what our competitors offer, and it gives you the ability to do more faster. Now, what is new? Well, we've been hounding the VMM team for about 6 years now, just continuously. Guys, we love your product. It's absolutely fabulous. We love it, we love it, we love it, except it's not extensible. Pretty please give me an extensibility model. Well, in SCVMM 2012 SP1, we got it. They gave us the ability to add UI add-ins, and we took that advantage to fulfill the request that we were getting most often, which was for a cloning, the equivalent of what we call rapid cloning utility, or the RCU over in the VMware side of the house. Our customers wanted the same thing inside VMM. So in this latest iteration of our on-command add-in, we do ship a SCVMM UI extension. focuses around virtual machine cloning and provisioning. We support both template-based as well as cloning of existing VMs for dev and test work. And again, under the covers, it's leveraging that same FlexClone technology. If we click the button, it's a real simple wizard. This is a V1 integration point for us. It's the first extension that Microsoft's given us. We're going to continue to iterate on this heavily. But this is targeted more at the mid to small tier. Guys who aren't going to actually implement full-blown clouds, they just want virtualization, which is fine, by the way. If you don't need a cloud, you don't need a cloud. It's okay just to take SCOM and SCVMM and Server 2012 and go and fix the business need, because that's the goal. The goal is to fix what the business needs, not to build a cloud for a cloud's sake. But if you do need a cloud, well, in the Microsoft world, that's going to come through the self-service portal, and the self-service portal is bled and driven through through Orchestrator. And we happen to believe that our orchestration integration is where we really shine. This is where we pull away from the pack. This is what made us and got us nominated as a finalist for Best of TechEd in the server management category. It was what we did with Orchestrator in our Microsoft Private Cloud Fast Track program that got us in there. We do ship Orchestrator integration packs. We have 29 built-in high-level workflows. But of course, we have that toolkit. Right? We have those PowerShell commandlets from before that we talked about 40 minutes ago. Those commandlets are really where the power comes in. You take the PowerShell commandlets, you tie them up with Orchestrator and its abilities, and now you start to get next-generation software-defined models today. So this was the qualification environment that we did with Microsoft when we did our actual fast track certification for the launch of Fast Track V3 at MMS this past year. One of the requirements was to do bare metal provisioning of a physical Hyper-V host. And we could have done what everybody else did and just leverage SCVMM to do bare metal provisioning. So here we've got our data management cluster, our fabric management cluster rather. Then we've got an app cluster. This is where the actual tenant VMs in our cloud environment are going to run. So we could have taken this and just gone up there and said create and add new hosts, but instead we decided to, well, if we're building a cloud, let's build a cloud. So we created a self-service service offering. We're going to go in and provision a new FlexPod VM host. This particular service offering only has a single parameter. Everything else is derived from the CMDB. So we just have to give it a host name. We could optionally give it a UCS server pool to target a particular part of your data center. For the purpose of the demo, we set it to auto-approve so we don't have to go to Server Manager and go through all that jazz. So we'll just hit refresh. We'll see the approval process finish. And now we see that the add VM host is actively running. So now we'll flip over to Orchestrator. That runbook takes us from a bare metal host, or a chunk of hardware, collection of hardware, to a running Hyper-V VM running inside a cluster. And as you're going to see here, it does it in a speed that is otherwise unimaginable and not possible. I don't care if you get all the SSDs in the world, copying data takes longer than not copying data. It's that simple. Right? So our trick is to not copy data. So here what we're going to do is we're going to clone the service profile inside UCS Manager. Then we're going to trigger a service profile association. It's going to take a couple reboots, so that takes a little while. While that's running, we're going to leverage the parallelism available inside Orchestrator. And we're going to go through and zone out our fiber channel fabric. And then at the top here, this is where the magic happens. We leverage FlexClone to clone from a bare metal LUN. Then we're going to mount that LUN to a midwife host where we're going to inject a custom sysprep into it, which is going to do the network configuration, the domain joins, rename it, all that fun stuff. And then we're going to take that LUN and mount it to our physical host. So now let's hit play, and we'll see this run in real time. The only thing we're going to cut out of this is the reboots. So here we see UCS Manager, our service profile pops in. We select it. We're waiting on the association process to start. So there the association process starts. Now at the same time, the fabric's being zoned, the LUN's getting cloned, it's mounted, there's a lot of stuff going on. You saw we fast forward through the association process, there's 2 reboots in there. Now, if we refresh this, about 5 minutes has elapsed. We're over here. We're at the sysprep wait. The server doesn't know it yet, but it's fully provisioned. We provision Windows in about 90 seconds, actually. That's how long the clone and injection process takes. The rest of the time, we're just waiting on reboots because we've got physical hardware instead of VMs. We have actual buses that have to spin up and get lit up. So there we've got the post-process script that configures our Hyper-V virtual machines. And there we can see the VM that we entered in the self-service portal is the name that we entered in the self-service portal is showing up inside Server Manager. So that's about as hard as we could get. We said, you know what, let's just show that it's all possible, and on the way out we're going to add it to VMM because we want it to be manageable in the long term for an extended period. So we took the hardest possible use case, which was let's do data center level deployment of bare metal. That's the hard part. Installing SQL or Exchange, that's trivial. That's an MSI installer. The hard part is getting the platform, is getting Server 2012 to the part where it's online, it's manageable, it's part of a domain. Once you have that part, you're done. The rest is simple. Right? So this is what we mean when we say software-defined models. This is management through a web page. Right? So now your admins, self-service, even internally, instead of going through and running a bunch of scripts or running some processes, just go to a web page, enter a name, hit enter, and 20 minutes later you got a host. So that's what we mean by software-defined and agile models. So, wrapping this up, because we're coming to our end, what if you could deploy private cloud in days instead of months, rapidly provision virtual machines and physical Hyper-V hosts via Orchestrator, and achieve non-disruptive operations across your enterprise while being able to backup and restore services instantly and integrate with self-service portals? Well, at NetApp, the complete solution that we've built out to demonstrate this as a reference to our customers is found in our Best of TechEd finalist solution, the FlexPod with Microsoft Private Cloud reference architecture. This is a fast-track 3.0 validated design, so we have gone through with Microsoft and gotten a stamp of approval. It is based on the FlexPod project, which is a joint collaboration between NetApp and Cisco. And we believe it to be the most scalable Hyper-V platform on the market, bar none. It gives you the ability to accelerate private cloud deployments at reduced risk, and all the hardware components are available now if you're interested in this particular thing. But honestly, the reference architecture is the interesting part, because it shows you how to put all this stuff together. And it's incredibly complicated to build the first time, but once you get the blueprint of how do you actually put it together, how do you build the storage, how do you put the cluster together, how do you get System Center to really work in this private cloud architecture, that's what the reference architecture does. So it accelerates those deployment models because it reduces the risk. You don't have to do any guessing games. And please, thank you all for attending this early in the morning. Vote for us for Best of TechEd. This is a big deal. We're a storage company. What the heck are we doing in this storage and virtualization management category? It's kind of insane. We really want to take this home. Now, of course, FlexPod's kind of huge. We've got one running on the show floor if you want to come by and see what it looks like. Just geek out on the hardware. It's absolutely gorgeous, the design that went into it, if you're into that stuff. But it's big. What if it's too big? What if you don't need that much horsepower? Well, that's where our ExpressPod offering comes in. We have our ExpressPod with Windows Server 2012 reference architecture. We have an ExpressPod on the floor if you want to take a look at that as well. This is an entry-level reference architecture. So this is for SMB to MBM, as well as the branch and extended branch. It's iSCSI only, so we're not doing SMB 3.0 and all the converged models, because again, we're right-sizing it. If you're looking at a two-node reference architecture, the equivalent of a CIB, then you don't need a self-service portal, right? There's economy of scales, and you're not crossing those lines. And all hardware and references available now. So, thank you very much for getting up this early in the morning in this beautiful city that likes to keep you out late at night. What do we talk about today? Well, we talked about software-defined data centers, this emerging technology trend that we've observed inside the industry, and how it's giving us the ability to deliver IT agility to application owners and development teams. We're getting IT out of the way, and we're letting the business do what the business does, and it's enabling IT to get more done faster, right? It's just this difficult transition that we're going through right now. And how do we do that? Well, we do that with Server 2012 by delivering a manageable platform that delivers performance to the end user. And in NetApp's instance, we're delivering portability from containers and cloud platforms. And then we've got the Microsoft Private Cloud Platform in System Center 2012 SP1 and our integrations with the stack there, an Operations Manager, Virtual Machine Manager, and Orchestrator. So with that, thank you very much. Resources for more information on this, of course, you've probably seen this slide everywhere you've been this week, are available. Please give us a vote and a rating inside ComNet. Best of TechEd, and of course, 5 stars for this presenter. Enter to win, and there's your QR code if you want to do that. With that,
So do we have the Surface to give away?
yeah, we'll do that.
As well as time for Q&A?
Yep. So with that, thank you very much for attending. We're going to give away a Surface Pro, so you don't have to go stand in line. And we'll take any questions you guys have.
Any questions? Somebody's got to have one.
Nope, we did that good.
Seriously.
Yep.
You killed it.
Does anyone not have a ticket? Raise your hand. Yes.
So let's restate the question.
Yeah.
So that everyone can hear. So the question was, correct me if I misstate this, if we could speak a little bit in greater detail to our software-defined storage, and then
Yeah.
Yep. Yep.
Yeah.
Sure. Sure. So the question is, how does the software-defined storage work in terms of enabling an application team or an end user, et cetera? Do you want to take a swing at this?
Sure. So you're right, we did cover a bunch of different integration points. But the reason we do that is because at NetApp, instead of building a monolithic tool and then coming to you and saying, this is how it works, we think that's how it works. Instead, what we've done is we've embraced, we played this game of pop-up mole. I can't remember the name of the game, but whack-a-mole. Thank you very much. We played whack-a-mole with data center management. And as a trend or a partner started to emerge and a model started to emerge, and we saw customer uptake and adoption through our extended partner network, we target engineering resources on those integration points. So we've kind of let the industry tell us how it's going to manage these, and we've just made sure that we have the integration and the plugins where our customers are demanding it. So we're not trying to solve that top-level, complete end-to-end model. We do offer solutions in this space because some of our customers do want to come with a pure NetApp solution. We have our workflow automation and on-command management suite products for those purposes. But honestly, most data centers, most customers, they already have solutions in this space. They're not looking for us to reinvent it. They just want us to give the integration with what they're already doing.
I would add to Glenn's comments, when you look at how the majority of data centers operate today, when there's a request from an application team for infrastructure resources, quite often that involves a ticketing process. Even if the front end is automated like a web system, it eventually gets to the point where it lands on the desk of a storage administrator. And he's got to look at some charts or look at some tables and figure out what's the workload look like, what array could I put it on, what class of service are you looking for from a performance perspective, what class of service are you looking for from data protection, all these input variables, of which those are just a few, and then someone makes a decision. And what we're seeing is this shift in the enterprise to have services delivered more like we receive as consumers with our mobile devices, right? I want a new application, I just go to the iTunes store, or I go off to the marketplace and I purchase and it comes down and I have it on my device. So I'm going to take 5 or 4 years for this to become a norm within the industry. But that model of self-service portals where the ticket request is now all delivered based on software-based logic and policies versus having someone sit at their desk and try to find where the resource should go. That's really the end goal of software-defined. At the end of the day, what are we eliminating? We're eliminating all that time. We're implementing consistency, and should something be provisioned, some resource be provisioned on day one, and the life cycle of the application need either increase or decrease, whatever that may be. The ability to dynamically resize the storage resources appropriately to best meet the economic or the ROI model of providing storage for that application. So at a very high level, you could say, yes, it's all automation, but it's having to break apart physical devices into logical so that we can really get granular on the consumption.
Yeah, it's really it's risk management, right? There was a time when deploying a server required a lot of calculations because if you didn't buy the right one, you were kind of screwed. There was no way to correct that mistake.
What about storage? If you didn't pre-provision
Exactly.
all your LUNs and
so now,
manually configure the partition starting and offsets?
So now with the combination of virtualization and these software-defined models, now mistakes aren't game-changing. It's just a correction. So if you deploy it on the wrong pool, you just move it to the right pool. If it's too big, you shrink it. If it's too small, you grow it. If the VM needs more memory, you add it. So we can kind of just throw it out there and for the first time ever, observe the application in the wild and then intelligently right-size it as we go. And that's something that's very easy to automate. Right? That kind of right-sizing is very trivial. What's harder is the problem that we're really trying to solve, which is to be able to do intelligent placement up front and be able to pick the right source the first time. But yeah, we'll get there eventually.
What we've shared with you here was a number of the integration points. We gave a high-level overview. Yeah. There's a significant amount of additional storage capabilities, such as never migrating your data again once it sits on a NetApp. We can move it through different storage tiers or to different controllers based on cache or performance needs. And again, without ever reconfiguring your application or even letting the application owner know there was an issue. We see an excessive amount of spikes in terms of latency, and we just move the data set. And I'm not talking temporary storage tiering, I'm talking right-sizing through the life cycle of the application. And so these are just one of many conversations that, when looked at in whole, start to become software-defined.
Anything else, guys? Yeah?
Here, PowerShell commandlets, I know we're talking about Server 2012, but we're not all there yet. Is there a particular version of PowerShell and/or OS?
Certainly. Yeah, so the question was, what is the minimum version of PowerShell required for our PowerShell commandlets? The Data on Tap PowerShell toolkit is PowerShell v2, so we'll run on any PowerShell v2 platform. It does require .NET 3.5 be present. Other than that, we have no hard requirements. So PowerShell v2 engine, so we're a module, we're not a snap-in, and we require .NET 3.5. That's it. We'll run with any version, Windows XP, 2008, 2008, anything. V2 and later, yeah, we're fully compatible with v3. We're working real hard to get some of the goodness in v3. We've got our IntelliSense working, pipeline binding, early binding. We're adding updatable help. So I'm a PowerShell evangelist through and through, and I'm making sure that our integration is the best in the industry. So we need to get a build of that first. But yeah, we'll make sure that we will be V4 ready the day it drops. Yes, sir. Yeah, so we have it. I have the run book sitting on our private cloud infrastructure down on the show floor. I can give you a copy of it if you got a thumb drive, but we're not hiding it, right? By the way, that from the ground up engineering to build that the first time took me 10 days. So think about that investment. This is why self-service is so important. This is why these models change how you do business. If you can lock away one engineer for a week and a half, you can remove the pain of deploying a physical host. So now you start taking that and go, okay, well now that pain's gone. So now let's take the next one. Maybe that's deploying SQL. Now that pain's gone. If you can just get to the point where you can get that first little iteration to start down the automation model, you get into these continuous cycle points where you go from a very physical manual process to a highly automated agile process. And then once you get to the top of that pyramid, that's when you just throw self-service on it and your business really explodes. That's when you give your end users the ability to get what they get when they need it. Because quite frankly, either we deliver this service or they're going to Amazon because the business can't wait. It's got to make money. That's what it's there for. Or Azure.
Yep.
It's going to the cloud.
So we've got a minute and a half left. One quick question if anyone's got one. Oh. Yes. The question, did you hear that? So the question was, should we defrag?
No. It buys you if you're running on Data on Tap, defrag buys you absolutely nothing.
So I'll go a little bit deeper. So we've had conversations with defragmentation teams, both third-party and native to operating systems. And unless you have an application that writes files that are less than 4K blocks, you won't see any advantage to defragmentation on NetApp. In fact, you'll take data sets that are deduplicated or cloned, and you'll rewrite all your data out, and then we'll come right behind it, and we'll put it all back. Yeah. Well, yeah. So the comment here, so those who didn't hear, referred if the block size is that small, it may be misaligned. Actually, any time that you're writing a data set where the file size is consistently or smaller than the block size, it's very hard in the storage array. So yeah, we've had a customer, probably the biggest gain I ever saw to defrag was customers whose app wrote at 512 byte size files. And then we just, they had to defrag every night or performance just fell off a cliff, but that would affect everyone. But outside of that, and you get into applications that have their own page sizes within their applications, or just an app that's just writing within the 4K boundaries of NTFS, it's not an issue.
Last one, real quick. Got it. So on a NetApp controller, we're using the same offload token engine. So we're actually calling the same exact copy. It's a sysclone under the covers. The difference is in how the protocol is implemented. VAI obviously is an in-band SCSI command, where here we're actually passing these tokens. So the offload speed and performance is roughly equivalent, but it's how the protocol works, right? We're never going to be able to do cross-protocol VAI because they would have to implement a token-based process. That's the only way you can do that. So
there's also the token-based process also gives you an exact feedback of where the copy operation is. So both in your reporting tools as well as fail jobs, that currently doesn't exist in vStorage API in the copy offload. You get an estimation of where you're at.
Alrighty, guys, we want to get you out of here so you can get to your next session. Thank you very much for joining us today. I hope you learned something. If you want to know anything else about NetApp Private Cloud or the future of the market, come see us down on the booth. We're willing to talk to you. Okay, so now let's have a little bit of fun. We've got a Surface. Somebody's getting one for free. Everybody get your ticket out in one hand, throw your hand up the other one. Keep your hand in the air as long as you are in the game. Come on, get them up.
He's going to read the numbers.
Let's go.
Everybody's hands up.
All right. 4, 2, 6, 9, 4, 1. Come on up, sir.
All right. Awesome.
No, the girl in the back will.